All right, let's do this. We've got 3 more. This is part 4, I think, of factoring using special products. Here I've got x cubed plus 64y cubed. So again, factoring's in the palm of your hand. I'm just going to keep saying that. Greatest common factor, not there this time. Binomial, got that. 2 terms. So difference of squares, no. Sum of cubes, absolutely. That's what I've got. So let's, I'm going to be using this formula, a cubed plus b cubed. So I need to find out what a and b are. A is going to be the cubed root of x cubed, which is x. My b is going to be the cubed root of 64y cubed. Please do not see 8 at 8y because it's not 8y. 8 is the square root of 64. I want the cubed root of 64, which again is 4. So 4y. Now I can plug these into the formula, kind of like I did in the problem right above it. So x plus 4y times x squared minus 4xy, right, a times b, plus 16y squared. That guy's done. In fact, the only difference between that and the guy right above it is hopefully answering the question, what happens if you have an extra variable in there? You know, like the first one right above it didn't have a y here. This one does. So as you can see how things unravel, my middle term has xy, my last term has the y squared. So hopefully it's not too trivial. The next one, hopefully you've already figured out on your own. Y cubed minus a, again, no greatest common factor, rule of thumb. Binomial, it's not the difference of squares, it's not the sum of cubes, it is the difference of cubes. So I'm going to use this bottom formula here. My a is going to be y, my b is the cubed root of 8, which is 2. Okay. People sometimes say, well, isn't it a negative 2? Nope, because the signs are hardwired into this little formula we use. Okay, so just work with the positive root there. So let's plug it in. A minus b, or y minus 2. And then a squared, so y squared, plus ab, so plus 2y, right? Like the coefficient before the variable. And then finally plus b squared, or 2 squared, which is 4. A lot of people mess up on the last one. They'll actually be writing 2 instead of the 4. They get all worried about, gotta remember the formula. Okay, I got the formula. Gotta remember to input everything in the formula. Okay, I got that. Then they forget the very last part. Alright, so make sure to get every piece of the puzzle. Okay. Alright, going after the last one. Rule of the thumb, greatest common factor. Boom. Got that. X squared comes out. Okay. Pull that out. Let's see what we have. We've got 27 minus y cubed. That is the difference of cubes. So don't forget your x squared, that's part of the answer. I'm not going to do the a and b little thing showing that. Hopefully you're figuring it out at this point. Cubed root of 27 is 3. Cubed root of y cubed is just y, so I'll go 3 minus y there. Alright, so then the trinomial part is a squared. If you figured it out, the a is 3. So square root of 3 is 9. Plus, right, opposite sides here. A times b, so 3 times y. And then y times y, which is y squared. There it is. You could also have done this, by the way. Instead, if you don't like seeing that negative y cubed, if you like seeing the y cubed be a positive value, then you could have factored out a negative x squared. What that would have done is it would have given you y cubed minus 27, right? Opposite signs there. And that gives you positive y cubed right there. Then you have a negative x squared. But a lot of people like to do that. They like to factor out the negative right away. So what will your answer look like? The negative x squared, don't forget it. And then the a minus b, so y minus 3. That's a quantity of y squared plus 3y plus this answer to the one right above it. This 9 plus 3y plus y squared, compare that to the y squared plus 3y plus 9. They're the same thing. I just use a commutative property and rearrange things, but the signs are all there. It's the binomial that's different. This had 3 minus y, but then a positive x squared out in front. Here I've got y minus 3 with a negative x squared out in front. Okay, but they're equivalent statements.